And then can I borrow an iPad? It's not like huge. Perfect. All right. All right, so when you are in your NCAD cloud, do not use that chair, put it back. Find a different seat. Just find a different seat. All right, when you are here, please go to your Canvas. And if you open this up in ClassLink, it is not going to work the way I want it to work for you guys tomorrow. That's why I'm having you go through NCAD cloud. So once you're here, give me a thumbs up, please. Lizette, get your stuff and move to a different chair, please, different table. Okay, you are going to go down to math and you're going to click on math. Tomorrow, when you log in to do your work, you are going to be working on word problems to review for your test that you're going to be taking on Monday. You are not going to use this home screen, this home page. You're actually going to go to modules. And you are going to scroll down to, obviously not today, because that's our lesson for today, but click on Friday. And we're gonna create a page in our notebooks today before you leave for your work. But if you click on the word problems, it will open up, it should open up right in Canvas. Alright, this is not what I want. I don't even know what just happened.
You have to scroll down.
Yeah, I don't.
At the top.
This is not, I don't want it like this. How many of you guys have used the Canvas app before? Okay, so let's try going through the Canvas app. So the Canvas app is just a little circle, looks just like the Canvas button. Perfect. So you should get to this screen with the Canvas app. You're gonna go to math. It's a little bit different setup, but you're gonna go to modules. Same thing, you're gonna go to Friday. And then you're gonna click on your word problems. And it should open up differently. And the way that you know that you did this correctly is you're gonna see this little marker right here in this top corner. That's what you want. You wanna be able to see that marker, okay? That marker is going to allow you to click on it, you can highlight, you can, whatever you want to do. For tomorrow, you are going to be annotating your questions here. Okay, so you're going to highlight the information. You can even circle your answers on this page. I don't know what is going on over there. You don't need any of that out right now. You should just be focusing on your iPad. So, on your iPad, you are annotating your questions, and you're also, if you want, you can circle your answers on here, okay? Your work does not go on this page. Excuse me, your work is gonna go in your notebook. Does that make sense? So, we actually, before we move on with our lesson today, are gonna go in and label our pages for today, but you're gonna have at least 2 pages, if not more. We're only gonna label 2, but if you need more, you can definitely use more. But we're gonna do that today. This is where the work is gonna go for these questions. Does that make sense? Does anybody not understand? We're good. So are you doing your work here?
No.
No, you are not doing your work here. You're doing your work in your notebook. And if you forget that, this is being recorded So you can be like, I think Miss Kenny told us, but I'm not sure. You can go and watch the beginning of the video from today that's gonna be posted on Canvas to find out exactly where you're supposed to put everything. Does that make sense? Any questions? What?
We circle the answer on this, right?
Whatever you wanna do. If you wanna circle your answer on here, you can, or if you just wanna put it in your notebook, you can. But you have to annotate on this page, okay? Alright, any other questions? Yes?
Are we labeling, are we just?
Baby, we ain't even got there yet. We're asking about this.
So you want us to, submit that?
You're not submitting anything. Did I say submit? No. Y'all, listen, you're not submitting anything. Zero submissions. You're not submitting, you're not submitting, you're not submitting. You are annotating the word problems that I just showed you and doing your work in your notebook. We are going over these, or some of these, or none of these, depending on what you guys want to do on Monday. And then you're starting your test. Alright, there's no submission. Alright, will I be checking your work on Monday? Yes. But you're not submitting anything on Canvas. You are simply annotating on Canvas. You must make sure you go through the Canvas app in order to be able to highlight and all that on your page. Does that make sense? So are you submitting anything to Canvas?
No.
One more time?
No.
Are you sure?
Yes.
Sure. Okay, now, close your iPads. Get rid of those for now. In your notebook, on the next blank left page, so this was our cool down from yesterday, you're crossing out the right page, going to the next blank left page. We are doing 2 lessons in one today, which will not take us that long, believe it or not. Huh? Can you just let me be the teacher? And I do apologize for today, your pull down is on a boring white piece of paper, so I'm sorry for that. Damien?
Yep.
Got him? Yes.
I can't fully see what it says on the first page.
Says Unit 1, Lesson 13, 14, polyhedra, and nets and surface area.
Okay.
Okay, let's see. Where's Caleb? Here today. Caleb,
Here about answers.
question. Trevor's here today?
No.
Okay. Sorry.
Pardon the interruption. Just to note that there will not be football practice today. No football practice today due to the weather. Thank you.
Alright, so go ahead, turn your page in your notebook. This is going to be a remote learning day. So the word problems that we just looked at and said that's where you're annotating. Like I said, you can use more than 2 pages if you need, but this is what you're going to be titling it. So Unit 1, Word Problem Review, 9/30, Remote Learning Day, and then the same thing on the right side. Unit 1, Word Problem Review, 9/30. Alright, so go ahead, turn back to this page, and then we're going to get started with our lesson for today. So we are moving into talking about essentially 3D shapes. That's a polyhedron. Any 3D shape is a polyhedron. Now, look over here real quick. We went ahead and annotated our essential questions. Our essential question was, how do you use finding area of irregular shapes to help you, or to find the area of series of 3D shapes? So they talked about area being the inside of a two-dimensional shape. They talked about irregular shapes, obviously with no even sides, not regular. And a regular shape that is two-dimensional is a parallelogram, trapezoid, rectangle, square, triangle. I think that was all that they came up with. And then surface area, we talked about being the area of the shape of a 3D shape. And then we also talked about 3D shapes being an object that isn't flat and it's 3-dimensional. Okay, is there anything you guys want to add to our essential question for today? Do you feel like they covered it? Got it? Okay. All right, cool. So, your warm-up for today is, what is a polyhedra? You have 5 shapes across the top. These are polyhedras. And then you have 4 shapes across the bottom. And I'm not going to give you figures, just because we can use these shapes right here. And we'll save the time for the other activity that we have today. So what you're doing independently is you're looking at these shapes compared to these shapes. And you're answering number 2. It says, what features help you distinguish the polyhedra from the other figures? So looking at these, what helps you distinguish that these are polyhedra compared to these? Okay, I'm going to give you 2 minutes. You're going to write down whatever you can think of right down here under number 2. All right, go ahead. Alright, so let's talk about what all we noticed. So what do you notice about these figures up here? Luke?
I noticed that they have either an open space.
Up
or they
here?
have- Or no, I was talking, or the ones on the top have sides that you can count and multiply, or sides that are closed figures.
Okay, so let's go with closed figures. And you said, sides can be multiplied?
Added. No.
Okay, so closed figures. Alright, let's start with that. Jackson?
All the sides are congruent.
Everybody knows what the word congruent means?
Yes, ma'am.
Anybody not know? Okay, good. Alright, what else? Jackson?
All the ones on the top are all kind of like polygons. They're kind of like polygons.
So made up of polygons?
Yeah, they're like.
I keep breaking my pen today. Say it again?
The ones on top are like 3D polygons. The ones on the bottom are kind of like polygons. Or they're odd.
Okay, so we're gonna go with just the made up of polygons. Alright, there's still a really big one that should really stand out between the top and the bottom that is very important that we know. Dax?
The top is mostly squares and triangles.
Okay, so if it's squares and triangles, what kind of edges do we have? No. Like, so, and this is very important that you guys understand, like, so these, you're right, they're made up of squares and triangles, so I agree with that. But the edges on the top 5 compared to some of the edges on the bottom 4, we need to know, we need to make that very specific. Yes?
They're curved and not curved.
Alright, so polyhedra, are they curved or not curved?
Not curved.
Okay. And Dax, you said they're made up of squares and triangles? Alright, let's get one more. Alright, Luke?
The polyhedras have angles.
Okay. Alright, so just for you guys to, for the most part, to understand, there are no open spaces in a polyhedra. They're all closed. There's no curved sides, and they're made up of polygons. Okay? Alright, so it says here are polyhedras called prisms. So slide over to A through F. So these are all prisms right here. And then these 4 right here are pyramids. So let's talk about, what do you notice about the sides of these prisms up here? What do we notice? What do we notice? Joshua?
Some of the sides are parallel.
What?
Some of the sides are parallel.
Parallel? Which would make them, so like each one of these, the sides are what shape? So look, so the sides on this one, 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 and the sides of this one are all the same shape. What shape are they? Don't look at me. Look at the shapes. Look at the shapes on your page. What are all of the sides of A through F? Not the bases, but the sides. You're thinking too hard. What is it? No, baby, not the angles. I need the side. What's the, what? Yes, they're rectangles. They're made up of rectangles. All right? So all sides are rectangles. All right, and it's very important because that is very specific to prisms. On your prisms, each one of these sides are rectangles. Now their bases are different. The bases are the top and the bottom. So like the base of A, what shape is that?
Triangle.
It's a triangle. So that's a triangular prism. All the ones in this one are squares. So what type of shape is this?
Square.
No, it's a cube. All right, this one, the base is what shape?
Triangle.
Triangle, so it's a triangular prism. This one, which we don't learn about, but what is the base?
Pentagon.
Pentagon, so it's a pentagonal prism. This one, technically it's a square, but we don't call it a square, we're gonna call this a rectangular prism. And then this one is a hexagon. Again, we don't learn about hexagonal prisms. Is it a hexagon?
Yeah.
One, two, okay, sorry. But essentially the four that we're gonna be learning about in 6th grade is your triangular prisms and your rectangular prisms and your cube. Okay, these two are just here to show you that a characteristic is that all of the sides of a prism are made up of rectangles. All right, so what else did we just learn about their bases then? What did we learn about their bases?
That there's always different bases, like there's different bases.
So how, they're all prisms, right?
Yes.
But how do we know if it's a triangular prism, a rectangular prism, a hexagonal prism? How do we know that? Jackson?
You know, because depending on the base will form the shape.
So the base names the shape.
Yeah. Like, it's base is triangle.
Okay, so let's say the base names the prism. So we use correct terminology. All right, what else do you notice about your shapes from A to B, or A to F, sorry. Joshua, are they teaching you or am I? Okay, don't pay attention out there. All right, what else do we know about A through F? Nothing? Bradley?
There usually are at least two sides that are the same.
Okay. Two sides, usually the same. Okay, anything else?
They all have ankles.
Well, pyramids also do that too. So we're not gonna say that. All right, so now let's look at the pyramids. So we have P, Q, R, S. So what is unique to our pyramids? What's unique to the pyramids? All right, Luke.
They all have. They have a triangle, but then they also have a different shape for the base, and they have like a hexagon or a square for its bottom. And
Okay, so let's make this easy. What are all the sides? What shape are all the sides?
triangle.
All right, so all sides are triangles. Are all the triangles the same size on the sides? Yeah, they have to. Why do they have to? So why do all of these triangles that make up our sides have to be the same?
So that they don't overlap each other and fall down
Right, because they all come to what?
together and touching at the top.
So, all sides are the same. 10. And then, your pyramids are named off of their base. So like for the first one, it's called a triangular pyramid. Why is it called a triangular pyramid? Alex? Because the base is a triangle, right? Well, what about this one? What do you think we'd call that next one? Based off of the shape of the base.
Cubic pyramid?
Nope.
Square.
Square pyramid. Yep. All right, what about the next one?
Hexagon and, oh wait, no, it's not a hexagon, that's a prism, or, wait, no,
I'll ask you for the next one.
okay.
Okay? Isis. Oh, sorry. Anna.
Wait, it's the third one, right?
Yes, ma'am.
Pentagon,
Pentagonal
pyramid.
pyramid. All right, so again, your base will tell you what the name of your pyramid is. What's the last one, Claire?
A hexagonic pyramid.
Hexagonal pyramid, perfect. All right, anything else we want to add?
There's no top side.
There is no top side, right? And there's no top side because what do all of our sides do?
They come together.
Come to, we said top, let's use a mathematical word and they come to a vertex. Okay, you guys remember what a vertex is?
Nope.
It's a point. All right, so question number 2 is actually on this page, and then we're going to flip over to our next, at the top of our next page, but it says, which of the following nets can be folded into pyramid P? So look at pyramid P. What kind of pyramid is that?
Triangular.
Triangular pyramid. So now let's flip our page over, and we're looking at net 1, net 2, net 3. So I want you to stand up if you think net 1 will fold into that pyramid, the triangular pyramid. Nobody think so? You do? Okay. So 2 people. All right, have a seat. Stand up if you think that net 2 will fold into that pyramid. Okay. All right, and then stand up. Have a seat, sir. If you think that net 3 will be folded into that triangular pyramid. Okay, so net 3 cannot. There's no way. No way. Net 2, definitely. But net 1 can also be.
Huh?
All right, because net 1, you'll fold, 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 and it all like folds together and becomes a pyramid. All right, we are not doing this part, so just cross out that part. All right, slide over to lesson 14. Guys, there is entirely too much conversation. Please stop. All right, so lesson 14. We are starting with this warm-up. It says each of the following nets can be assembled into a polyhedron. Match each net with its corresponding polyhedron and name the polyhedron. Be prepared to explain. So you're looking at A through E, and then you're looking at 1 through 5. So you can draw a line or just write the letter and then write the name that you think goes with it. I'm going to give you 3 minutes. If you finish before then, you can stand up. No, this is independent. Alright. A. So A goes with which number? What was that? Say it again, baby. 3. Yeah, so A goes with 3. And then what is the name of A? What's the name? Luke?
A square prism.
No.
No, a square pyramid.
Pyramid, yes. Okay, because remember, it's made up of, the sides are all triangles, that's how we know it is a pyramid. Alright, B, which one does it go with? Alright, Caleb.
The 2.
Okay, so B goes here. Caleb, what's the name of it?
Rectangular prism.
And how do you know it's a prism?
Because, well, it was shown on the page.
It was, but what are the features of the rectangular prism? All the sides are what? What's the name of it?
A rectangle.
So all these sides, technically, these long sides are rectangles, so it's made up of rectangles. Does that make sense? Because a pyramid, all the sides are made up of what? Yeah. Does that make sense? Cool, cool. All right, number, letter, whatever, C. Who have I not heard from today? Kylie.
4.
Yep. And what is the name of it?
A triangular pyramid.
Yes. See, you know. All right. D. What is D? Caroline.
D is shape 5.
Okay.
And it is called a rectangular prism.
Nope, it's not rectangular. Look at the bases.
I mean, triangular.
Yes.
Triangular.
No, it's not a pyramid. It's a prism, yes. So this is a triangular prism. Why is it a triangular prism? Let's talk about this so that we make sure we know and understand. Bradley, why is it triangular?
Because it has like rectangle, because it's in the shape of a triangle.
No.
Well, the side, two of the sides are in the shape of a triangle.
Which those sides are what? The
Top and bottom.
so they're the bases.
Yep.
Yes. So the reason it's the triangular prism is because it's the bases are triangles. Then, why is it a prism?
Because the sides are rectangles.
Perfect. All right. Does everybody understand that? It's really, really important because prisms and pyramids are very different, but they're very easy to get confused. Okay. Is there anybody who doesn't understand?
Can I go to the back?
Not in the middle of my lesson. Sorry. Like, if you can hold it, I just gotta give directions and then, are you good?
Yeah.
Okay. All right, and then obviously the last one, E, is going to be which one? Michaela? 1, and what is the name, Michaela? This is a cube. All right, in a second, you are going to get a cutout for your group. All right? Now, you are going to essentially get one of these 3 shapes. So before I even give you these shapes, let's go ahead, and technically you have to do this on the next page, but we're gonna do it on this page. What shape is A? Look at A and tell me what shape is A. Jackson?
Rectangle.
Nope.
Rectangular prism.
Yes. And how do you know it's a rectangular prism?
Because the sides are not all the same. And if they were, they would be a cube.
And they're all made up of what? So there's no triangle, so therefore it's not a triangular prism. They're all rectangles. All right, B. What is B? Look at B. What do you think, Jakai? Yes, ma'am. This is a square pyramid. And C. Be careful with this one. Be careful. What do we think? All right, Anna?
Rectangular prism.
No. Why is it not a rectangular prism? Jackson, let me ask you this. Why was yours a rectangular prism?
Because they were made up of rectangles and there were no triangles.
Right. So this is a rectangular prism because they're made up of all rectangles. All right. C has rectangles, but not all of them are rectangles, right? So, Sophia. No, y'all, no. Look at the shapes. Look at the shapes. What is C made up of?
Rectangles and squares.
Rectangles, technically, because squares can be rectangles can be squares. So rectangles and triangles. So if you see 3 rectangles and 2 triangles, it has got to be what? Triangular
Prism.
prism. It's got to be a triangular prism. It cannot be a pyramid because it's only got 2 triangles, and it cannot be a pyramid because it's got rectangles. All right, now flip your paper over. Like I said, you can just leave if you wrote the names on the front side. You don't have to rewrite them. But your group is going to get one of these. You're going to cut it out and create the 3D shape that this is going to make. Now, my advice to you, before you cut out, I would find the area of each one of these shapes and put it on here. Okay? You're going to see dotted lines that are outside of the dark part. Make sure you cut those out so when you fold it and put it together, you have somewhere to glue. Because if you cut those off, you won't have anywhere to glue. There's glue in your bends you can use. If you want to use tape and you have your own tape, then you can. Sorry. Alright, as soon as you get this, we can go ahead and get started. You won't have a ton of time, but you'll have at least enough time to get it cut or to find the area.
We got this. So.
When you are finished, come show me the area, your shape, and hold on before y'all get started. Look at number 3. It says find the surface area of each polyhedron. That is where your work goes. So let's say that Michaela is gonna. It's yeah, it's my phone. Hold on, guys, chill. All right, stop. It's not a big deal. Calm down. All right, so, because this is important, this is how you get your cool down for today. So, you find your surface area. Your person, so Michaela is my person for my group, right? So she's going to bring her shape, put all together, and her paper with all of her work on it. She's going to show me this. She's going to show me her shape. I'm going to say good to go, hand her cool downs for everybody in her group. I'm going to say no, you need to fix it. All right, that is how you get your cool down today. Any questions? Anybody not have a shape? That might be on your iPads too. Or somebody's phone if it's on. Because my phone is off, so it's okay. It's okay. It's not a big deal. Hey! Chill out. Is your phone turned off? Just to silent now. Whoever phone it is. Just make sure it's on silent. Alright, go ahead, get started.
Okay, so 3